we're going to start with a review of some topics that are going to be important this semester. And so really there were two key topics I want to talk about, so the outline. First one would be functions, and the second one would be exponents. So we're going to start by focusing in on functions first. So let's look at an example of a function. Consider the function f of x is x squared plus 9. And I want you to evaluate the function at the following values. F of 1. So remember, when we have a function, we think of x here, this is the input, and then whatever you get out, that would be the output. So I'm plugging in 1 in place of x, and I'm outputting 10. Now you can plug in numbers that are not just whole numbers or integers. You can plug in like pi. It would be pi squared plus 9. You can even plug in fractions, 1.1. And this would be 10.21. You can plug in fractions, 1/2 squared plus 9, 1/4 plus 9. If you get a common denominator, this would be 37/4. But you don't have to just limit yourself to inputting in numbers. You can also input in variables as well. So for example, if I'm thinking of a as being some kind of number, I don't know what it is, you can plug it in. So go back to your formula. Everywhere there's an x, you're going to replace it with an a. So this would be a squared plus 9. We're also going to see later this semester, I need to plug in x plus h in place of x. So everywhere there's an x, you're going to replace it by x plus h squared plus 9. And now, don't forget, for this part right here, you do need to FOIL that out. You'll get x squared plus 2xh plus h squared if you FOIL all that out. So for functions, think of them as having inputs and having outputs. Let's look at our next example. Let's consider the function x plus 3 divided by x minus 2. Now I do want to mention that this function, it's a polynomial divided by a polynomial. This is called a rational function. And let's look what happens when I plug in numbers into this. So let's start by plugging in 1. Right, 1 plus 3, 1 minus 2. You'll get -4. I can also plug in 0 into this function. 3 over -2. What happens when I plug in 2? Well, if you look at the denominator, you get 0. So what this means is that my function is not defined at 2. So I would say f of 2 is not defined. let's look at one more function. Let's consider the function. It's going to be the absolute value of x divided by x plus 1. And let's plug in some values into this function too. So let's plug in 0 into the function. What are you going to get if you plug in 0? You get 0 over 1 or 0. What happens if I plug in -2? So the absolute value of -2 is +2. And I get -2 as the output. What happens when I plug in -1? -1. Again, if you look, you're going to get 0 in the denominator here. So f of -1 is not defined. So keep in mind when functions are defined and when they aren't. You might want to think in terms of domain of functions. All right, so let's look at our second topic, which was, said it was exponents. And the main thing to keep in mind with exponents are how to simplify exponents, i.e., we want to talk about the exponent laws. So I'm going to write the law down here, and then in the second column, I'm going to give you an example. So the first exponent law says when you have a base a to the 0th power, it's 1. So for example, 2 to the 0th power is 1. When I have a to the x, a to the y, the way we combine those is we add powers. So an example here would be maybe 2 squared and 2 cubed. They would combine to 2 to the 5th. I add the exponents together. When I have a power, so a to the x to a power to the y power, when you have a power to a power, you multiply a times xy. So for example, I have 2 cubed to the 4th. This would be the same thing as 2 to the 12th. If I have a times b to a power, I can split it up or combine them. So for example, if I have 2 cubed and 3 cubed, they have the same exponent, so I can combine them into 1 power, and it would be 6 cubed. You have a similar rule for division. So if I have a over b to the power x, it's the same thing as a to the x over b to the x. So an example here would be if I have 4 squared over 2 squared, the exponents are the same, so you can push them together into a single exponent, 2 squared, which is 4. And the very last rule with exponents is if I have a negative power, a to the negative x, you can turn that exponent positive by moving it to the denominator. So for example, 1 over 2 to the negative second, this is the same thing as 2 squared, or 4.